Hello there. Now, hopefully you've got your light show done, and I don't want to leave the impression that the only thing you can do with Arduino is flashing lights, because we just use flashing lights to sort of help us understand how we can program the Arduino. But there's so much more you can do, and there's all these components and everything that you can buy and use. And one of the things that we were going to do is work with this little guy here. So of course, obviously we can't. Let me just move back a little bit there. Obviously we can't, but sort of right in here is the Arduino board. It's a little hidden by this shield, which connects to a variety of different motors and sensors. So what we'll do, something a little bit easy, well not easy, but a little bit related to this is what I'm trying to say, is we'll look at how this ultrasonic sensor works. So this is actually sending out sound waves, and then with it bouncing back, it will be able to measure the distance. In a way, this is a little bit like a self-driving car. Obviously, cars are not using, they're using either radar or LiDAR, laser radar, or cameras to gather information, but this is one way of doing it, being able to sense the distance by, like I said, how long does it take for that ultrasonic, so we can't hear it, it's beyond our hearing, but how long it takes for that to go in. So if I just turn this on here, and it's not going to do much, there's a little bit of another thing there. There's a little bit of a servo motor here to let it turn so it can look left and right. So if I turn that on, right, you can see, and it turns, and basically at the moment it would be sending out a signal. Now there's nothing I can do to sort of show that it's getting that, but the closer you got something, then it would detect and therefore be able to avoid collisions. All right, so what we're going to do this week is play around with this in the simulator. So what we'll do here is wire up our Arduino to control our, to use our sensor. So I'm just going to grab a good old breadboard. And what you want to do, these are the basic components. We're actually going to grab, just go with all here. And when we scroll down, you'll find that there's two ultrasonic ones. We want the one with 4 pins. So on mine at least, and I assume it's the same as yours, there is one, the second one here. And we'll just throw that right about there. It doesn't matter exactly, okay? And these are 4 pins. One you'll see that says VCC, that's gonna be your voltage, okay? Then it's got the trigger, the echo, and the ground. And so what we wanna do is be able to wire this up, and we'll go through that process in a second. Now the second thing that we're going to do is make sure we got our lights. Let me go back to basic here because for some reason my LED, there it is. I'm just going to grab 3 LEDs. And these 3 LEDs are just going to be visual indicators of how close the object is. And so I'm just going to grab those 3 there, and we're just going to hook them up just like we did before. So I'm going to take our resistor and making sure that those are on the negative side, which is the shorter one, right, the cathode, and do those 3. Good. All right, and then we're going to hook those 3 lights up to pins 2, 3, and 4. So I'm going to do that right now. So there's pin 2, pin 3, make sure they're in order here, and pin 4. Good. So those are hooked up. Another thing that we're going to do, just to make our life easy, don't zoom in. For some reason my mouse, okay, it's a little far out now. My mouse does not, okay, there we go. Okay, so what I'm going to do is put the ground in. That doesn't really matter. I'm going to put a ground maybe over here, and also a 5 volts. I'm just going to give power into this rail. Okay, so that's a little bit different. We're just putting 5 volts in there because that's what we're going to use for our source here. So I'm just going to grab this. Like I said, this one here is our voltage, okay? And then the GND is the ground. So I'm just going to put that right into there. Okay, so what we've got now is 3 lights hooked up, just like we did before. Nothing different there. We've got the ground, so that we've got this all set up as a ground. We've got 5 volts, which is a little bit different, but we've basically charged this power rail so it can put out 5 volts. That's why we can just attach this wire to here. So it's going into the sensor, this HC-SR04 sensor, which is really the ultrasonic sensor. And then we need to ground it right here. So basically that's just giving it so that it can make the sound, okay, and be able to, respond to the sound going out and then the sound coming back, right? So it's be able to sense it. What we need to do is attach these two, so the trigger and the echo, and we're going to attach them to 7 and 6 respectively. So what I'm going to do is just go from the trigger, which is the second one from the left, and I can just grab a wire and I'm going to put it on 7. And I'm going to do the same thing on the echo, but I'm going to put that on to 6. So now what we've got is this all wired up so that we can run it. Basically, the Arduino is powering all of these things. The Arduino is also going to be pulling in information from 7 and 6. So this actually makes 7 and 6, instead of output pins, input pins. And we'll see that in the code in a minute. And then these 3 lights, just like before, they're going to be output, because what's going to happen is this data is going to come in, the Arduino is going to process it and determine whether the object is close or far away. And depending on how close, or how far away, these lights will turn on or off. So the closer it is, I believe, we'll have 3 lights on, and then it gets a bit farther away, 2 lights on, and then 1 light on. All right, so now we're going to talk about the code. And just to make sure that we're very clear, we basically have 2 sections, right? One's going to be the lights, the LEDs. The other is going to be relating to the ultrasonic sensor. So the ultrasonic sensor is going to measure the distance, and then based on that distance, we're going to get a readout with our lights here. So let's just take a look at the code. At the very start, we've seen this before, and actually I can just change this to 330. There's a distance threshold. That is the maximum distance that this sensor can reach, and that's in centimeters. So it's about 3.3 meters, 330 centimeters. Then there's some measurements here for centimeters and inches that we'll use, and that's just, you can kind of see down here, just to give us a little bit of an indication of what the actual measurement is. So we have a rough estimate with the lights, and then a precise estimate down here. Now, just like before, we've got our setup function. And our setup function for these 3 here is nothing unusual. It is your pin mode, and those are 4, 3, 2. Those are your 3 LEDs there, set to output. This one's a new one, serial .begin 9600. This one deals with the serial monitor. We haven't used the serial monitor. What the serial monitor lets you do is get the sort of precise values, because the Arduino doesn't have a display. It can display it on the computer screen. So this is, you pretend, your computer screen down here, and we can see the measurements there. The 9600 is a baud, which is a bit rate. It's how fast the data is being transferred, and it's just, this is the typical value, 9600 here. Now there's 2 functions that we're just going to skip over here. One is the long read ultrasonic distance. We will talk about that later. Okay. The other, and you're going to sort of do this, is the light gauge, which I've called this, this silly thing, the light gauge here. And then we have our good old loop. And really, remember, this is where our actual program's basically running. And we're going to call those 2 other functions from here. So first thing, let's just change this back to 330 as well. It's going to set the threshold distance. We've already done that. We can do it again here. It's not really necessary, but we set that threshold distance. Now this here is a conversion, okay? And don't worry too much about the math. I'm waving my hands here. This is sort of the magic number that makes it work, okay? So what it's going to do is, to calculate the centimeters, it's going to multiply some number, we'll talk about this in a second, by 0.01723, okay? And we're going to multiply it by this read ultrasonic distance. So this is going to be a value that's coming out of the of our ultrasonic sensor. And notice here, 7 and 6. Those relate to the 2 pins, the trigger and the echo. So what it's saying here is run this function using pins 7 and 6. So let's go up and see what happens when we run this function. So I'm going to go up here. So the read ultrasonic distance, notice it takes those 2 values, 7, which was the trigger pin, right? So that's the first pin there. And then the echo pin, which is the 6, right? That's the echo pin. So you can see that those 2, right? And we can't see it on the Arduino there, but trigger and echo were those 2. So what it does, we've got a few steps here. And notice how similar it is to the digital write and stuff that we did before with the lights. There's a lot of similarities here. So again, we're setting up a pin mode. And the reason why we're doing it here is just nice to make sure it's all clean and reset, okay? So that's the trigger pin, which would be pin 7, okay? And it's setting it to an output. So value is going to come out to it. What we're going to do is we're going to make sure that there's no voltage going into it. What it's basically going to do is when that triggered, then it's going to start to send the signal. Okay, so we wait a little bit of a second just to clear everything. These are microseconds, so that's 1/1,000,000th of a second, 2/1,000,000ths of a second, just to give you an idea of how fast this is happening. Then we're going to turn that trigger on. Okay, so we're going to turn it on. So now it's going to be basically sending out an ultrasonic sound. Then, and so that's why it's set to high, it waits for 10 microseconds. So 10/1,000,000ths of a second. And then what we do is we turn it off. Okay, so we've got it on, beep, right, sending a signal, then we turn it off. Now what's interesting here is we turn on basically the echo pin. Okay, we say pin mode echo pin. Okay, we turn it on, right, sort of activate it. It's an input. It's going to take in a value. And what it does is there's a special function called pulse in, which is going to read that echo pin, okay, and it sort of basically turns it on there. Now why it says return and why this says long is because this is going to return, so it's going to bring out of the function a long number. And a long number is a sort of a big decimal number because we're dealing with microseconds. This number, this length is going, or distance sort of thing, basically the value is going to be a very, very precise value. So we're going to pull that out, okay, and that value is going to be right in here. So this times whatever number came out of that ultrasonic reading is going to turn it into centimeters, okay? And then right here, all we're doing is converting it for us to see how many centimeters and how many inches. Okay, we'll talk about light gauge in a second. Let's get this running. So I'm going to start it. So what you can see, let me just bring this over. If I click on this guy, and I'll have to zoom out a little bit, there we go. This is our object here, okay? And as soon as I put it inside, you can see now it is roughly 2 centimeters away. It's changing a little bit. It's not ultra precise. There's a little bit of variance in it. But obviously as I bring it in, okay, then we can see that it's come in. At a certain point, it's too close. Okay, looks like it can't go, and then it's actually lost it completely. So, and beyond here, right, like I said, if it goes beyond the threshold, it can't measure it either. So it has a certain range, but you can see that it measures the distance pretty well. We assume it's pretty accurate there. Okay, it changes quickly. Now, what we had there, of course, it was the lights showing up as well. So what I'm doing is just pulling in the centimeters, okay? So I'm going to call the light gauge function based on the centimeters that we calculated here. So let's go down, or go up, I should say. And really, this is just a series of, of if and else's, basically just ifs here. So I've got this light gauge. It pulls in the centimeters as the input. It doesn't return anything because we don't have a number or anything coming out. What it does is if it's greater than the distance threshold, so if the value is greater than 330, it's going to turn all the lights off. If it's between the distance threshold, so less than the distance threshold, so less than 330, and greater, so this is the and symbol, and greater than, so 330 minus 100, so it would be 230. So basically saying between 230 and 330, it's going to turn one light on, okay? Then the next one as well, so this is to turn 2 lights on between, 100 and 200, right? So this would be between, 230 and 130, so between 130 and 230, it is going to turn 2 lights on, and anything sort of that last bit, so anything less than or equal to 200, or sorry, that would be, do the math for me here, 130, right? So 330 minus 200, so 130. Anything less than 130, all the lights should be on. So if we take a look at that, make sure that's working. So we should have 3 lights on, 1 light on, okay, because it's beyond that. So if we bring it in closer, so that, what was it, in about there, so you can see 200, so it's just inside. So if I go beyond, so there's 240, it's not. But once I'm sort of 230, inside 230, 2 lights turn on. And if I'm inside 130, there we go, all the lights come on. Okay, so it's just a visual indication of where it is. And that's really all it is. Okay, it's kind of a cool little thing. If you go back to that robot, right, inside the robot, we're sort of measuring those distances, and then based on it, maybe it's going to speed up or slow down if it doesn't sense anything far away. Like if it doesn't sense anything, then, maybe go at full speed. As you get closer, as something's sort of approaching, well, then maybe you should be putting on your brakes. So you could imagine it in that way. All right, yeah. Then, so of course it did the light gauge. Then there's just a delay, and that's just 100 milliseconds. So 100, yeah, 100, 100 milliseconds, so the easiest way to say it, 0.1 seconds. And that's just to let it stop for a second and then remeasure it. If you do it too fast, it's sort of pointless, right? You get too much data in here, and it might even just make it slow down a little bit too much. So that's why we've got it there. Good. So now you've got a working ultrasonic monitor. Good.